not so exceptionally distant from Earth. Generally speaking, researchers have found a new planet known as Proxima b. Stargazers, as of late, uncovered the most keen picture ever captured of Proxima b, using the notable James Webb Space Telescope. This planet orbits the star closest to our Sun, and this wonderful picture offers a remarkable look into a world outside our nearby planetary group, raising questions and excitement among researchers overall. Yet how did this telescope accomplish such an achievement? Could this picture open up a window into a place that could have conditions appropriate for life? At last, what does this new discovery mean for how we might interpret exoplanets and the immense universe beyond? Join us as we explore the newly uncovered clear picture of Proxima b, captured by the James Webb Telescope. Proxima Centauri b sits inside the vastness of space surrounding its star, Proxima Centauri, a simple 4.2 light-years away from Earth. This far-off world has captured our imagination, raising inquiries about its likeness to our planet. Might it at some point be likened to Earth, facilitating seas and abounding with life? Adding to the interest, Proxima Centauri isn't alone. In its journey, it shares an orbit with another sizable planet, Proxima Centauri c. Proxima Centauri b gets about the same energy from its star as Earth gets from the Sun, making researchers curious about whether this distant planet could harbor water or support life. As we explore the endlessness of space, we encounter various exoplanets, worlds circling stars other than our Sun. With a bewildering 206 trillion stars scattered across the universe, the opportunities for these exoplanets seem unlimited. A portion of these planets wander freely through space, similar to enormous migrants. Proxima Centauri stands out as a unique riddle in this broad array of celestial bodies. Its year is surprisingly short, lasting just 11.7 Earth days, and it circles a star about 20 times closer than Earth does to the Sun. Thus, one side of the planet is constantly washed in sunlight, while the other remains in endless darkness, adding to the planet's strange and possibly wondrous nature. Proxima was initially discovered using the radial velocity method, an Earth-shattering procedure in finding exoplanets. This method depends on observing the subtle movements of a star caused by the gravitational pull of a circling planet. As the planet orbits its star, it makes a small but discernible movement, causing the star to shift slightly in its orbit. Space experts spot this development by carefully studying changes in the star's spectral lines, a phenomenon called the Doppler shift. For Proxima b, these small changes in the star's spectrum revealed the presence of this far-off planet, displaying the radial velocity method's effectiveness in uncovering worlds outside our nearby planetary group. Recognizing Proxima b was a critical accomplishment since it confirmed the presence of an exoplanet within the habitable zone of the closest known star to our Sun. This discovery ignited tremendous interest among researchers, specialists, and space enthusiasts overall. They are anxious to explore the potential mysteries Proxima could hold, and what this finding means for how we might interpret the universe and the possibility of life beyond Earth. Proxima Centauri b is an infinite wonder worth marveling at. Picture 3 celestial companions, Regulus, Canopus, and Proxima Centauri, moving across the vastness of space, forming the closest star system to our own. As we look into the night sky, Regulus and Canopus merge into a brilliant guide, shining together in the Carina constellation. These stars rank as the third most brilliant, stunning us with their splendor at a peak magnitude of 0.27. However, it's the modest Proxima Centauri that holds an intriguing secret. Also alluded to as Alpha Centauri, this red dwarf from a T-type class lives just 0.21 light-years from its brighter companions. To put it into perspective, that's multiple times farther than the distance between Earth and the Sun. Its name, Proxima Centauri, meaning closest star in Latin, highlights its status as our closest celestial neighbor. Back in 1915, Scottish cosmologist Robert Thorburn Innes revealed this divine diamond to the world. Regardless of its proximity, Proxima Centauri remains tricky to the untrained eye, bearing an apparent magnitude of 11.13, far beyond a naturalized visibility limit of 6.5. Nonetheless, it's an achievement in its own right. Red dwarf stars, like Proxima Centauri, are enormous forces to be reckoned with, effectively producing energy through strong internal convection processes. This star will happily maintain its position as a primary sequence star for another 4 trillion years, exhibiting a lasting brilliance that spans the ages. However, the concept of habitability around Proxima Centauri comes with its fair share of challenges. Being a flare star, Proxima Centauri experiences sudden and unusual eruptions of energy. Its lower mass suggests that any potential habitable zone where life-friendly conditions could exist is much closer to the star compared to our Sun's habitable zone. And Proxima b, a planet situated within the zone at a distance similar to Earth's orbit around the Sun, faces unique difficulties. Appearances can be deceiving. Proxima b battles with intense ultraviolet radiation many times more intense than the sunlight reaching Earth. This extreme radiation poses a danger even to hydrogen atoms, imperiling the stability of essential elements like nitrogen and oxygen. Furthermore, simply occupying a Goldilocks zone doesn't guarantee a sustaining environment for life to thrive. Proxima could lack the vital environment necessary to support life, manage climate, and cultivate a surface suitable for water. Without the protective shield of a vigorous atmosphere, any potential life forms on Proxima b would be exposed to the brutality of space, significantly reducing the likelihood of life as we understand it. The mission to uncover the secrets of Proxima b, despite its challenges, remains a driving force in the realm of space exploration. Among the tools fueling this invaluable research, the James Webb Space Telescope stands out. Launched toward the end of 2021 after numerous delays, this cutting-edge telescope holds the promise of shedding light on one of the most tantalizing questions in cosmology. Does life exist on Proxima b? The path to uncovering the truth about Proxima b is far from straightforward. The James Webb Space Telescope underwent significant adjustments to ensure the accuracy of its images. According to a renowned theoretical physicist at Harvard, Proxima b requires a nuanced approach. Situated inside the habitable zone of its star, the planet has the potential to absorb and emit life-sustaining infrared radiation, making it detectable by the James Webb Space Telescope. This advanced instrument can capture faint light from the planet's surface, aiding researchers in their search for signs of water or an atmosphere. The crucial question of whether Proxima b has water plays a significant role in interpreting this nearby exoplanet. The presence of water substantially affects the potential for life as we understand it. Water, a fundamental component for life on Earth, if found on Proxima b, would greatly increase the likelihood of the planet being habitable, or at least capable of supporting some form of life. Proxima b, located within its star's habitable zone, receives the same amount of solar energy as Earth receives from the Sun. However, due to its proximity to its red dwarf star, the planet faces intense stellar radiation and magnetic activity. These factors could challenge the stability of any potential atmosphere. Furthermore, the presence of liquid water is still in question. Currently, scientific models and simulations are being used to investigate different scenarios for Proxima's environment and possible water reserves. Some hypotheses propose the existence of vast oceans on the planet, while others suggest that any water may be trapped as ice or buried beneath the planet's surface. Directly identifying water on Proxima presents an imposing challenge, requiring advanced telescope technology and specific atmospheric conditions. As our observational tools continue to advance, the mystery surrounding Proxima b's atmosphere and potential water reserves is expected to unfold, bringing us closer to truly understanding the nature of this captivating exoplanet. Yet, the presence of an atmosphere alone doesn't guarantee Proxima B's habitability. Ed Turner, an astrophysicist at Princeton University, cautions against assuming habitability based on an atmosphere alone. He warns that the planet may resemble Venus, with a thick choking atmosphere and extreme heat, rendering it unsuitable for life as we currently understand it. Proxima b, beyond being just another distant exoplanet, emerges as a fascinating neighbor in our vast backyard, tantalizing us with the possibility of life-sustaining conditions. Its proximity to Earth makes it an attractive target for future space missions, sparking the interest of cosmologists and space enthusiasts alike. Although direct travel to Proxima b remains beyond our current technological capabilities, it holds a place on the horizon for potential interstellar missions. The challenges inherent in reaching Proxima b are indeed immense. A journey using existing spacecraft technology, exemplified by Voyager 2, would require an astounding 23,000 years.